During this last autumn, you have seen me do a lot of prototyping on the Wintergatan YouTube channel, and each and every single prototype test is giving me information that I can use to do the CAD design of my new marble machine. And in this video, I want to make one last test of 2023. I want to see how the speed of the programming wheel is affecting music tightness. And this is something that I've been thinking about a lot. And thanks to this brilliant prototype rig, I can test this very easily. So what I'm going to do is that I'm going to run a test at normal speed, and then I'm going to change out the gear for a gear twice its size to make the wheel go twice as fast. And here's my thesis. I think the faster wheel will play tighter music. But why do I think that the faster programming wheel will play tighter music? Well, here's an illustration. If we rotate this point around at a certain speed, and if I count from now till now, you can see that the point has covered this big area during that time. If we now double the speed of the point, and I say from now to now, you can see that the faster point covered twice the area in the same amount of time. This point is correlating to our programming profiles. Our programming profiles will never be perfect. There will always be some tolerances. So imagine that we have some error in the programming profiles, for example, from here to here. The error of the programming profiles can be illustrated as this yellow area in our illustration. The slow dot will spend more time inside this error area, the yellow area. And in this case, it can give a music error up to 4 milliseconds, whereas the fast dot spends much less time in this yellow error area and can only make music error of 2 milliseconds. This is why I think the faster programming wheel will play tighter music. But let's try for real. We start with a slow example. This is the standard setting that I've always used. The bass sound you hear here is the rotation of the flywheel, and then of course you can also hear the marbles hitting the plywood. So I'm recording this for a while, and then I'm changing the gear. So I'm changing a gear from 8 teeth to a gear with 16 teeth, which will double the speed of the programming wheel. So now I can record a new test with twice the speed of the programming wheel.
Kör vi igång den här festen?
As you can hear, the flywheel has the same speed and the programming wheel plays twice as fast. Now I can analyze the audio in Titanator.fun, and from there I can export a CSV file with all the raw data that I can import in a spreadsheet and do some analyzing on. And the results shocked me at first. The faster flywheel played 9 times tighter music, and I was like, this cannot be true. So I checked manually, and indeed, this was not true. This was a measurement error. When I checked in Logic, this first instance where Titanator.fun said that the transient differed 14 milliseconds. In real life, it actually only differed 1 millisecond. So I experimenting with EQing the audio differently to make Titanator.fun see the transients a little bit better, and we had a completely new results with that. So now the slower flywheel had 2 millisecond standard deviation and the faster had 1 millisecond standard deviation. And this is actually really interesting because when you're measuring something, you need to be able to trust your measuring tools. And Titanator.fun is amazing, but sometimes it can detect peaks in a strange way. So I cannot always trust the data blindly. But to be able to trust this new data even more, I also checked manually. So I checked each and every difference manually in Logic Pro, and I could actually verify this number manually. So around 2.5 millisecond for the slow wheel and around 1.4 millisecond for the fast wheel. So my thesis was correct, that a faster programming wheel plays tighter music. So here's the problem with this new information. If we make the programming wheel spin around super fast, the length of the music we can program on it will be super short. So we have to strike a good compromise between a nice music length and a fast enough rotation to get the music tight. Anyway, if you think that the videos this autumn have been a little bit all over the place, there has been a lot of method to the madness in my head, at least. I'm hoping to start the new year with a full project update video and tell you how all these prototyping fits in to the project as a whole. I think I have found a lot of great design solutions. The Huygen drive, the flyball governor, a lot of pieces to the Marble Machine puzzle has now fallen into place. And I'm really excited to try to continue laying this puzzle in a very methodical and efficient way in 2024. New Year's is my favorite holiday. It always feels like I'm getting a new chance. That's why I'm so pumped about it. So I wish you all a very happy new year and see you 2024.